Hello friends. Now today in this video I'm going to tell you one of the tricks to solve one particular type of questions involving maxima minima of modulus. Alright, so let's have a look at one specific type of question. Here you are given an expression y equal to modulus of x plus 3 modulus of x plus 1 plus modulus of x minus 2 plus modulus of x minus 7 and so on. Now this type of questions can be divided in two parts. Now part number one, here the number of moduluses is odd. Okay, and then in second part we'll look at another example wherein number of modulus signs will be even. So let's have a look at this one first of all. Now here you can see 5 modulus expressions separated by plus signs. Okay, now first thing you have to do is you have to find out the nodal points. That means the values of x for which each of these modulus is equal to 0. Now the first modulus will be equal to 0 when x is minus 3. The second one will be 0 when x is minus 1, then 2, 7 and 11. Now we have obtained 5 points. Alright, the number of points is odd. Remember this particular thing. Now what we'll do is we'll now represent these 5 points on the number line in increasing order from left to right. Okay, so I'll draw a number line and will represent these 5 points on the number line from left to right. So minus 3, minus 1, 2, 7 and 11. Important to represent these 5 points in the increasing order, not randomly. Now herein the number of modulus signs was odd. Okay, so first of all we'll find out the value of x for which the entire expression will attain its minima. So first thing, the value of x. Now here the value of x will be the middlemost value of all these 5 numbers that you can see on the number line. So here the middle number is 2. So at x equal to 2, this entire expression will attain its minimum value, right? Easy. So there is no need to spend a lot of time in these type of questions, and you can just calculate the value of x for which the entire expression will attain its minima in less than 10 seconds. Now the second thing which is important, the minimum value of y. Now you can calculate the minimum value of y by putting the value of x that you have calculated here. So if I'll put the value of x as 2 in the entire expression, I'll obtain the minimum value of y. There is another way of doing this, a faster way. So now look at these 5 points. First of all, calculate the distance between the two extreme points. Minus 3 and 11, the distance between them is 14. Then calculate the distance between the next two extreme points. So calculate the distance between these 2 points, minus 1 and 7. The distance is 8. Alright. Now take the sum of these two numbers. 14 plus 8, that is equal to 22, will be the minimum value of this expression. Easy, right? If you have 7 modulus signs, then again you can repeat the same procedure. You'll have to find out the distance between the two extreme points, then the next two, and then the next two. All right, and then you can add all these 3 distances and you will attain the minimum value of the expression. Okay, so that was part number 1. Now let's move on to the part number 2, wherein the number of modulus signs is even. So I have taken an example where the number of modulus signs is 6. So again, I'll draw a number line and will represent these 6 points on this number line. So starting from minus 3, minus 1, plus 2, plus 7, plus 11 and plus 17. All right. So first thing is the value of x for which the function will attain its minimum value. Now here in this case, when the number of modulus signs is even, then the function will attain its minimum value not for a unique value of x, but for a range of values of x. Now this range of values of x will be starting from the middle two values. So it will lie from the middle two values, like from plus 2 to plus 7 in this case. So what I have done is I have just selected the middle 2 points. The middle 2 points are 2 and 7, and the function will attain its minimum value when x will belong to 2, 7, both inclusive. So starting from 2 up till 7, for all these values of x, the function will attain its minimum value. All right. Now this was the first thing. The second thing, to find out the minimum value of the function, the minimum value of y. So in this case, again, what you can do is, first of all, find the distance between these 2 points, the extreme points, minus 3 and 17. The distance is 20. Plus the distance between the next two extreme points, that is minus 1 and 11. The distance is 12. And finally, the distance between the two middlemost point, 2 and 7. The distance is 5. And add these three numbers and you will obtain the minimum value of y. So 20 plus 12, that is 32. 32 plus 5 is 37. So 37 will be the minimum value of y for this particular expression. Now this particular thing can be replicated to any number of modulus signs, right? So we have seen plenty of questions coming in CAT over the previous years involving the same kind of logic.